Trigonometry, Chapter 1, Trigonometric Functions, Section 2, Angle Relationships in Similar Triangles, Video 2, Parallel Lines. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the last video, we discussed the angle pairs formed by two intersecting lines, and there were essentially two types of pairs. We had adjacent angles, and they were supplementary. There were four pairs. These two, these two, these two, and these two. But we also had vertical angles, and vertical angles were congruent. Recall that vertical angles are the two non-adjacent angles formed by two intersecting lines, and we had two pair, these two and these two. Now, in this video, we study the angle pairs formed by parallel lines, and you might be thinking, there are no angles because by definition, parallel lines do not intersect. So how can there be any angles to study? And the answer is we introduce what's called a transversal, which is just a line that intersects a pair of parallel lines like this. And now we have 8 angles, 1, 2, 3, 4, 5, 6, 7, 8. Now, angles 1 through 4 up here at the top, we already know how they're related to each other because this is just, where's my highlighter? There it is. That's just the four angles formed by a pair of intersecting lines. So we already know how they're related. The matching colors, the red ones, are vertical angles, or the blue ones, and they have equal measures. Different colors are adjacent and hence supplementary. The same thing can be said for 5 through 8 down here at the bottom. Where's my pointer? No, it's over there. Sorry about that. Oh, well. The same can be said for angles 5 through 8 at the bottom in terms of vertical angles, which are 5 and 8 and 6 and 7, and adjacent angles. But how do the top 4 compare to the bottom 4? Angles 1 through 4 compared with angle 5 through 8. And the answer is real simple. They're exactly the same. So in other words, the 4 angles at the bottom, watch them, the 5, 6, 7, 8, have the exact same measures as the 4 angles at the top. Imagine cutting and pasting the top 4 angles on the bottom 4, and it'll be easy to see. Now, all the angles in red are congruent to each other. All the angles in blue are congruent to each other. The red ones are 1, 4, 5, and 8. Blue ones are 2, 3, 6, and 7. Any pair of different colored angles are supplementary. If they match colors, they're congruent. If they're opposite colors, they're supplementary. That's what I was trying to say. Now, among these 8 angles are 5 specially named pairs. I'm going to go through them kind of quickly. Corresponding angles are 2 angles, one from the top and one from the bottom, that have the same relative locations. In this picture, angles 1 and 5 are corresponding, as are 2 and 6, 3 and 7, 4 and 8. And notice that each pair is the same color. Corresponding angles are congruent. Same side interior angles. It's a mouthful, but there are 2 angles that are between the parallel lines on the same side of the transversal. There's 2 pairs of them. 3 and 5 are same side of the transversal interior of the parallel lines, as are 4 and 6. And if you notice, each pair is opposite colors, which means same side interior angles are supplementary. Same side exterior angles is the same idea, except outside of the parallel lines. There are 2 pairs of same side exterior angles. 1 and 7, notice they're opposite color. 2 and 8, notice they're opposite color. Opposite color in this picture means supplementary. Same side exterior angles are supplementary. Alternate interior angles are 2 non-adjacent angles that are inside the parallel lines on opposite sides of the transversal. 3 and 6 are alternate interior angles, both on the inside on opposite sides and not adjacent. 4 and 5 are alternate interior, and you may have noticed that each pair is the same color, which means they're congruent. And finally, we have alternate exterior angles, which is the same thing except on the outside. 1 and 8 are on alternate sides of the transversal exterior, non-adjacent, as are 2 and 7, and as you can tell from the colors, they're congruent. Now, there's so many angle pairs. There's 5 names, some are congruent, some are supplementary, and it makes you want to go, argh! But all you need to remember is that each pair is either congruent or supplementary. And if you can copy the top 4 to the bottom 4, it'll be real easy to keep that in mind. Don't worry too much about the names, but I will be using them. Just remember, every pair of angles in this picture is either congruent or supplementary. Now we're going to take a look at a quick example where we consider this diagram and we're looking to find the measures of 4 angles. Now, how can we do this? Well, we have to connect the information that we're given into an equation that we can solve. So let's look at angles 1 and 4. They are alternate exterior angles. They're on the outside of the parallel lines, not adjacent, opposite sides. Alternate exterior, which makes them congruent. If you weren't really sure what you can imagine doing, if I can get this drawing to work, is you can imagine taking this and cutting it and pasting it down here. And when you do that, the 3x plus 2 would land right here, which is a vertical angle to that one, which means that they are congruent. So we put 3x plus 2 equal to 5x minus 40 and solve it. Subtract 3x from both sides. 5x becomes 2x. Add 40 to both sides, so the 2 becomes a 42. Divide both sides by 2 to get 21. That's not an angle, but we can substitute the 21 into the measure of angle 1 to get 65. And since 1 and 4 are congruent, angle of measure 4 is also 65. Now, what about 2 and 3? Well, angle 1 and 2 are supplementary. They're adjacent. So the supplement of 65 is 115. And 1 and 3 are vertical angles. So they have equal angle measures of 65 degrees. All right, now you try. Pause the video and try the following problem. Find the measures of the 2 labeled angles. For clarity, both of those are inside the parallel lines. All right, spoiler alert, if you haven't paused the video and tried to solve it, I'm about to unveil the solution in 3, 2, 1.